in this work, I try to present to you some work, some analysis using the cancer data. So this is the visualization of the response variable cancer and non-cancer. You can see that the cancer, which is labeled 1, has 42 observations, and the non-cancer 37 observations. So try to do some analysis to find out the 9 most important variables. And as you can see, displayed by their p-values, we have from 1 to 9. So p-value, smallest p-value means that the that variable is highly significant. So we also used the Kruskal-Wallis test to plot the test statistic for the top 9 variables, and that is a plot. The variables are plotted in order of importance, and this is a box plot of the top 9 variables to see which of these 9 variables will be able to categorize the cancer and the non-cancer groups. Then also we built some tree on these variables. So the complexity of the tree here is 0.01, as you can see. So the tree has 4 terminal nodes. So for an individual to be in each of these groups, then these 3 variables are important. This is also the box plots of the 9 weakest variables in this data set. So this is a correlation matrix of the 9 strongest variables, the most important 9 most important variables in the data set. And as you can see, some of them are highly correlated. This is a table showing the eigenvalues from the correlation matrix. And here you can find the ratio of the lambda max to that of the lambda mean. And lambda max is the highest eigenvalue and lambda mean is the lowest eigenvalue. So their ratio will be 17. The ratio is 17.03. And this is ROC curve for the 6 machines on the cancer data set. So here it turns out that the 1NN is the model that does well, and it makes sense because it has highest complexity, but it might also overfit. It is also prone to overfitting. Yeah. We also try to fit some trees using different CPs, and these CPs are the complexities. So as we increase the CP, and then the the model becomes better because the CPU of 0 will tend to overfit the data set, although it is good, but it will overfit it. And this is the ROC. I have the ROC analysis for different models, and this is the ANOVA for the test errors of the 6 different models we built. So the p-value here, which is significant, approximately 0, tells us that at least there is a difference between one pair of these 6 models. But we can't know unless we go further to do post-hoc that we can truly show that the difference lies in these 2 models. Okay. Then also we'll go to the exercise 2 of this work. So the first part, just trying to do the mathematical formulation of the prediction function of the KNN learning machine. So in this model, we are going to be using the MNIST dataset, which is a bunch of characters to be identified by these machines. So this is a confusion matrix for these um, models. Okay, and the p-value from the ANOVA tells us that the test errors for these models are not the same. So I've gone ahead to do the post-hoc to show where the difference lies. So this p-value adjusted here, any p-value that is greater than 0.05 shows that in that group, there's no significant difference. Okay. And the Second part of the exercise 2, we'll try to split the data into various forms. Okay, I use 5, I use 1 and then 5 and then 7 and then 9 and then and 30 video.